In this program, we'll be overloading the greater than operator, less than operator, and equal to operator. And these are the objects which will be compared with these operators which are being overloaded. Now, what are these magical functions, how they are invoked, and what is the output that they return? Not only this, we'll be learning how to overload the plus operator to add to strings, to add to complex numbers. So watch the video up till the end. Because operator overloading is a very big lecture, so I have split it into two parts. In this lecture, I will be overloading this plus binary operator, less than sign, greater than sign, and equal to operators. In the next lecture, that is in 26b, I will be explaining you how to overload the unary operator and how to overload plus equal to operator. So let us start with this lecture. See, here let me tell you that whenever you overload any operator, internally a magic function is called. For example, when you overload a plus operator, this is the magic function. This is also known as a special function. See, the functions which are prefixed with 2 underscores and which have suffix as 2 underscore are known as special functions, right? And they are automatically called whenever you overload any operator. How will I get the list of all the magic functions or all the special functions? This is the URL where you can get all the magic functions. See, LT, LE, this is invoked when less than equal to operator is overloaded. This will be learning EQ. NE is for not equal to. So on this URL, you'll get the list of all the magic functions or the special functions. In this program, I'll be explaining you how to overload a plus operator, that is binary plus operator. We'll start from the main function. You are making an object theory obj of student class. On looking at value 70, the Python compiler will realize that there has to be a parameterized constructor. So the control will jump over here. This is the parameterized constructor of the student class. The 70 will be assigned to this m parameter, marks. And from the m parameter, the value will be assigned to the subject instance attribute of the object theory obj. Thereafter, the control will jump over here. You are creating another object practical obj and you are passing value 80. This 80 will be assigned to the m parameter, and from there it will be assigned to the subject attribute, and this subject is the instance attribute of this instance, practical obj. After that, forget about these two things. Here we are overloading. On the screen you get a text, total marks, then you are adding two objects. See, usually the task of the plus operator is to add integers, floats, right? But when you ask the plus operator to add strings or to add objects, you are overloading its work. You are overburdening it. It's not its usual work to add objects, right? So whenever you ask any operator to do some extra work, we call it overloading, right? So the moment compiler will look at this plus operator, it will realize that in this program there has to be a magic function, this add, right? And it will invoke it. Now let me tell you, this plus operator is invoked by theory obj, and this practical obj will be passed as a parameter to this sec obj. Sec obj, I am assuming it to be second object, right? So practical obj will be assigned to the sec obj, and what you are doing here inside in this function, you are adding the subject attribute of the object which has invoked this plus operator. Theory obj has invoked this plus operator, so the subject of this theory obj is 70, will be added with the subject of the sec obj, that is of the practical obj, that is it will be added with 80. The addition of 70 and 80 will be returned and displayed, so you get the output 150. So you have added two objects. At the moment you have only one subject. You can have 5 subjects, right? You can get all the respective subjects added through this binary operator overloading, right? Now let's try adding strings by the binary operator overloading. See, you are making an object primary enemy of student class, and obviously this bin2 will be passed as an argument and will be assigned to this m parameter, and from there this bin2 string will be assigned to the subject instance attribute. After that, the control will come over here. You are creating another object secondary enemy, and this harwani will be passed to this m parameter and will be assigned to the subject attribute of the secondary enemy. Thereafter, here the control will come. String concatenation is you are invoking the plus operator via primary enemy object, and the primary enemy object is the one which has the bin2 as a subject attribute assigned, right? And secondary enemy will be passed as an argument and will be assigned to this sec obj parameter. You are adding the subject of the object which has invoked this plus operator, that is subject of the primary enemy is bin2. It is added with the subject of the sec obj, that is subject of the secondary enemy object, and it is Harwani. So Bintu and Harwani will be added and will be written and displayed. Let us run this program. I have copied it and pasting it in the Spider IDE and I am running it. See, total marks is 150 because of this binary operator overloading of the theory obj and practical obj objects. String concatenation is Bintu and Harwani. See, there is a space between Bintu and Harwani because I have included a space within apostrophe. If I remove this space, Bintu and Harwani will appear without any space in between. Let us move on to the next program. Here I am explaining how to add two complex numbers through binary operator overloading. Now I will just run them and I will explain the output on the Spider IDE itself. I am just copying it and running it here. See, now this is the complex number 3 plus 2j. 3 is the real part of it, 2 is the imaginary part, right? So this program is adding two complex number. 3 plus 2j is added with 1 plus 5j. The real values of both the complex number will be added. The result will be 4. And the imaginary part of both the complex number will be added. 5 plus 2 is 7. Got it? Now, let us understand from the main function. You are making an object comp obj1 of complex class. And this 3 and 2 will be passed as an argument. On looking at 3 and 2, compiler will realize there has to be a parameterized constructor of the complex class. So control will jump over here. This is the parameterized constructor. This 3 and 2 will be assigned to these parameters R and I. R stands for real, I stands for imaginary. From this R and I parameters, the values will be assigned to the real and imag attributes. And these real and imag attributes are the instance attributes of the object which is created, that is comp obj1. When you display a object, this str, this special function will be executed. Recall from the previous lectures we've learned that when you print an object or when you convert an object into string by invoking str function, this special function having the 2 underscore as a prefix and the 2 underscore as a suffix is automatically executed. And what you get the output? 0, that means the first value, that is real, will be displayed here. Plus will appear. 1 means the second attribute, that is imag, will come over here, and j. So you get 3 plus 2j on the screen because of printing the first object comp obj1. Again you are creating another object comp obj2. 1 and 5 will be assigned to these parameters, and through these parameters will be assigned to real and imag attributes of the comp obj2 object. You are displaying the comp obj2 object, that is this str function will be invoked, and you get the output 1 plus 5j. See, after that you are invoking the plus operator. This comp obj1 is invoking the plus operator, and this comp obj2 will be passed as a parameter. So control will jump to this magic function. Comp obj will be assigned to this second object. You are adding the real attribute of the object which is invoked to this plus operator, that is comp obj1. So the real value of comp obj1 will be added with the real value of the parameter, that is comp obj2. These two values will be added. 4 will be assigned to this r variable. Thereafter the imag of the object which has invoked this plus operator, that is of the comp obj1, will be added with the imag attribute of this comp obj2. So these two will be added. Output will be 7, will be assigned to this I variable. You are invoking an object and passing these values r and I, that is 4 and 7. So this statement will invoke the parameterized constructor, and 4 and 7 will be assigned to the real and imag attributes of the object which is returned, that is of the object sum obj3 which is created. Got it? Thereafter on the screen you get a message sum of the complex number is, this is a message you get, and by printing sum obj3 you get the output 4 plus 7j. Now if I want the output as a tuple, I can return not the object, but I can only add the real values of both the objects and the imag values of both the objects. That's it. So the output you will get it in the form of a tuple. See, I am commenting out this. Right, and just run it. See, the output here appears to be because it's an object. Here the output comes perfect because these are the objects. Here you are not returning an object. You are just sending the sum of the real and imag. Right, a sort of a tuple is returned, which will be assigned to the sum obj, and you get the tuple displayed 4 and 7. Right. Now let us learn to operate less than sign, greater than sign, and equal to. See, here you are creating 3 objects. Stud1 obj of student class, stud obj2 of student class again. So 3 objects are created. stud obj1, stud obj2 and stud obj3 of student class. Let us understand what will happen when this first statement is executed. On looking at these four arguments, compiler will jump to the parameterized constructor in the student class here. And these values 101, bin2 and 1780 will be assigned to these RNHE, role, name, Hindi and English mark. And from these parameters, these values will be assigned to the role, name, Hindi and English attribute of the object which is created. That is stud obj1, right? And also, you are initializing another attribute total, which is nothing but the sum of Hindi and English marks, right? After that, stud obj2 object will be created and these values 102 Chirag and 7585 will be passed to these parameters, and from there these values will be assigned to role, name, Hindi, English attributes of the stud obj2 object, and also its total attribute will be computed. Similarly, stud obj3 will be created with these values 103, Naman, 70 and 90, which will be assigned to these attributes role, name, Hindi, English, and its total will also be computed. Now let's come here. You are comparing two objects, right? See, usually the greater than sign is used for comparing the logical expressions, but here you are comparing the objects. So the compiler will realize that there has to be a magical function and it has to be executed. And the compiler will jump over here and will invoke this magical function. This greater than operator is invoked by stud obj1, and this stud obj2 object will be passed as a parameter and will be assigned to this sec obj parameter. You are comparing the total of the object which has invoked this greater than sign, that is total of the stud obj1, that is 150, is compared with the total of the sec obj, that is of the stud obj2. The total of stud obj2 is 160. Is 150 greater than 160? No. So this magical function will return the boolean value false. Because the function has returned boolean value false, if block won't be executed, else block will be executed, and you get the output total marks of and the name attribute of stud obj2, that is Chirag. Total marks of Chirag are higher than marks of the name attribute of stud obj1, that is bin2. So you get the output total marks of Chirag are higher than marks of bin2. Got it? Similarly here, you are overloading the less than operator. This less than operator is being invoked by the stud obj1, and this stud obj3 will be passed as an argument and will be assigned to this sec obj parameter. You are comparing the total of the object which is invoked, this less than operator, that is stud obj1. So the total of stud obj1, that is 150, is compared with the total of the sec obj. Sec obj is stud obj3, that is 160. So is 150 less than 160? Yes. So this special function will return boolean value true. So obviously this if block will be executed and you get the output total marks of bin2 are less than marks of the name attribute of stud obj3 is Naman. So the output is total marks of bin2 are less than marks of Naman. Now here, you are overloading the equal to operator. Stud obj2 is invoking this double equal to operator. Stud obj2 is invoking the equal to operator, and stud obj3 will be passed as a argument which will be assigned to the sec obj parameter. The total of the object which is invoked this magic function, that is stud obj2, and it is 160, right? So is 160 equal to the total of this stud obj3? The total of stud obj3 is also 160. So is 160 equal to 160? Yes. So this magical function will return boolean value true. Control will come over here. This if block will be executed. Total marks of Chirag and Naman are same. Got it? So let us copy it into your Spider IDE and execute it. See, total marks of Chirag are higher than marks of bin2 because of this else block was executed, right? Total marks of bin2 are less than marks of Naman because of the if block being executed over here in the less than operator. Total marks of Chirag and Naman are same because this if block was executed here, right? So all the three operators are overloaded. If you followed this lecture, please subscribe to my channel, share the video with your friends, and do write comments. Thanks for watching the video. Have a nice day.